One of the most important things in data analysis and algebra, particularly for graphing, is understanding the difference between the independent and the dependent variables and how they relate to what we call slope or rate of change. The logic of choosing independent and dependent variables is what we're going to talk about, and then a little bit on slope and rate of change to illustrate the x and y axis and change in y versus change in x. So let's first of all go over some key terms. And the first one is a variable. A variable is anything that changes. Usually it's represented by some letter or some shortened name in an algebra equation, something like a y or x or a or b or p or q or p for or t for time, anything like that. An independent variable, I'll scroll down a little bit, the independent variable is the variable or quantity that changes with intent. In other words, we want that one to change and can control its movement, or it changes automatically, such as time. You know, we don't control the march of time, but we do vary a lot of things by time or with time. It's the controlling variable. The dependent variable is the variable or quantity that changes as a result of the independent variable. In other words, it's the variable we call the dependent variable is dependent on what's going on with the independent variable, or what's changing with, say, x. Okay. A slope then, and we've already talked about this in other lessons, but remember that slope is considered as same thing as a rate of change, and that indicates how much the dependent variable changes with a change in the independent variable. It also tells us whether the relationship is positive or negative. Generally speaking, for example, population growth in a city is positive. Not always, but usually is. Something that is negative would be, for example, when we showed an example in another problem or another section about draining a tank. The water level in the tank would decrease with time as we drain the tank, and so forth. Okay. Let's look at some examples here, and let's pick out which one is the independent variable, IV, and which one is the dependent variable. So the higher the temperature of water, the faster an egg will cook. So the question you ask yourself is which one is controlling and which one is a result. So does the temperature vary as the egg cooks, or does the egg cook as the temperature varies? Well, I think it's pretty obvious that we would say that the independent variable here would be the water temperature. Okay, water temperature. And the dependent variable would be the time, or the speed of cooking, right? The speed of cooking an egg. Okay, speed of cooking, right? And as I'll change that to cooking. Sorry, change of cooking. And I think we could agree that if the hotter the water is, the cooking time would go down. So this would actually be a negative relationship. If we had the number of minutes of cooking, here would be temp and cook time, we would expect that to go something like that, right? Second example here, an investigation was done to see if keeping the lights on for different amounts of time each day would affect the number of eggs that chicken lay. Which one do you think is varied? Do you think that the number of hours of daylight would vary with the number of eggs being laid, or the number of eggs being laid would vary with the number of hours of daylight? Well, again, the choice should be fairly obvious. We're talking about the number of eggs would vary with the hours of daylight, or hours of light. Okay, hours of light and egg production. Egg production would vary with that. Okay, here's the third example. The time it takes to run a kilometer depends on the amount of exercise a person gets. So what would you think there? I would think that the more exercise, the number of minutes it would take to run a kilometer would come down. And so, and both of these variables are, notice time is involved in both of these, okay? So because when it takes amount of exercise, that would be time of exercise, time of how much time we spend exercising, and the dependent variable would be time to run a mile or kilometer. To run kilometer, right? Now in this case, both of our variables are time, but the controlling variable would be how much time we spend exercising, and the result would be the time it takes to run a kilometer. The next one down, grass will grow taller if it is watered and fertilized. So we could say what depends on what? Well, the growth rate, or the amount of growth, would depend on how much water and fertilizer. So we would say that water plus fertilizer would be our independent variable. That's what we would control. And the result, or the dependent variable, would be how tall, right? Or said another way, the growth, right? Okay. And finally, the amount of algae growth in lakes seems to be directly related to the number of sacks of phosphate fertilizer sold by the local merchants. Now here's a case for a different discussion, but I'll just give you something to think on, is do you think the fertilizer itself feeds the algae, or do you think that perhaps the phosphates kill other things that would have eaten the algae, right? So there's cause and effect to be determined here, and if you take statistics later on, those are the kind of things that you get more involved in. But just for a simple graphing case like this, the sacks of phosphate would be the independent variable, okay? Sacks of phosphate. Just kind of squeeze it in there, and the amount of algae would be the dependent variable, okay? And so there's just some simple cases. I encourage you to go back and review those, and just think about other things that you're familiar with, things as mundane as, maybe not so mundane for some of you, but things like sales of blue jeans varies with the price, okay? What's going on there? That's an economic case, which is pretty easy to figure out which one is which. The sale price is going to influence the number of units sold. Okay, so let's take a look at a specific example and translate that to a graph. And let's look at the one with the egg production, right? And here's what we might expect. This is fictitious data. I just made it up for an example, so don't go, if you know somebody raising chickens, don't ask them to verify this. But egg production per week going from 0 to 10, and the number of hours of daylight going from 0, where we keep them totally in the dark all the time, to the lights are on all the time in the hen house. And what would you think? Well, the independent variable, the x-axis variable, would be the number of hours of daylight, and then the egg production would vary with that. That's the vertical or y-axis, and that we have that labeled as independent variable here and dependent variable here, and I hope that makes a little bit of sense to you. Now, what would be happening here is we could, from this data, we could create a slope, or maybe this slope or this graph was created from experimental data to give us that equation. But in any case, we could do the same thing we've been doing. We could calculate a slope of this line to get a relationship of what we call the rate of change of egg production with hours of daylight. Okay, so we could call that egg production, and it would actually be, in this case, weekly egg production, right? And this is kind of a wordy slope, or a wordy rate of change, but it would be weekly egg production varied with hours of light in a day, right? or per day, right? And so we could calculate the slope. We could take the first one down here. We could use that as one of our points, and we could use another one. We could use this one up here, or maybe we could use somewhere in the middle here. And what we would find out that as we change from 0 to 12 hours, that would be our change in x, right? And our change in y would be from 2 to 6. So we would have y2 minus y1 over x2 minus x1 would be, let's use these 2 points, this one and this one. They're easy to use. So it'd be 6 would be that minus 2, right? And then the hours of daylight would be had gone from, say, 12 to 0. And so we would have 4 per 12, or 1 and 3. Okay, and so we could say that if we did this and found this to be true, we would say that for every hour of daylight, in fact, this is a good way to go ahead and write this verbal expression here, for every hour of daylight, or let's just say light, because we can't get 24 hours of daylight, and it'd be artificial anyway, but light egg production can't write here, it's late in the day when I'm making this. Egg production increases by 1/3 egg per week. Okay, and I know it's a little bit hard to read, but you get the idea. And so that's what this is all about: independent and dependent variable. And we can graph that. We can use that when we analyze graphs and data such as that. Okay. One final thing, just as a summary here, and this is something you ought to keep handy. Is what about when we are looking at experimental data, or we're looking at cause and effect, and it's not specified in the problem which one is which, right? And you have to decide which one is independent, because you're going to graph this information and you want to present it, but you're saying, okay, which one is independent, which one is dependent? Okay, you always want to ask this question. Okay, it's which variable is controlled by or moves with the other. Okay. And so this would be controlled by would be the dependent variable, and this one would be the independent variable. Okay, because the dependent variable is controlled by or moves with a change in the independent variable. So a couple of examples. Does shooting percentage change with practice time, or does practice time change with shooting percentage? Does weight gain vary with calorie intake, or is it the other way around? Does population vary with time, or is it the other way around? Well, these answers are pretty obvious, and in fact, most of the time they will be, which is this next point. Most of the time the situations are easily discerned, but sometimes it could go either way. In other words, you may be looking at some experimental data, and they're showing a graph of pressure change and time, and you're saying, okay, which one's which? Well, we know this to be an important physical relationship, and so it could be either, you know, depending on which one was being controlled and which one was being measured as a result. You would have to look at the context of the problem. And any good science book or any good experimental lab book would tell you which one they want you to vary with the other, so you need to check that context. If it's not specified, then they didn't do a really good job of explaining the problem. But you want to determine, again, which is the cause, which one is the effect. Okay. One final thing, whenever you're looking at an experiment or collected data to analyze where time is involved as a variable, and we know only God can change the movement of time, so time marches on and it's always moving forward, it is most often the independent variable. Time is most often the independent variable, and other things are changing with time. Okay. Well, that concludes this analysis. The next thing we're going to work on, which is related to independent and dependent variables, and the movement between them and the relationship between them is this thing called domain and range. It's not a difficult concept, but it does give folks pause and headache from time to time. So look for the lesson on domain and range. That's a super critical concept in algebra. Okay, thank you.